Good morning, everyone. Nice to see you, everybody. Gonna have another Japanese start of the stream. So good morning to everybody. Let's get started. Let me know if the video is fine and everything is fine. My name is Yuri. I'm decomposing WebGL animations from the different websites. And today is gonna be no different. And you can already see the website behind me. It's gonna be replicating. It's a pretty cool idea. Looks quite amazing. Actually not that complicated to implement. And let's dig into this one. Hopefully this stream will be a short one. I mean, under 1 hour. And just to remind you, I'm still fundraising money and donations for my friend in the army. We already made a half of the intended sum, like $1,000 being gathered over just a couple of days actually since the last stream. And I'm still need another half. And I'm really grateful for like any kind of donations. A small one. Actually, the small ones are the best ones. Well, the big ones, of course, are the better ones. But I mean, yeah, you get the idea. Even the small ones matter. Hello, everybody. Доброго ранку, Україно. All right. Yeah, so let's get to business, right? Let's get to business. This is going to be the website I'm going to be replicating. And it's been asked by, actually, it's been in my pipeline for some time, but then I decided it's too easy. I mean, it's not easy, but it's too simple for a stream because I actually need something to do like for an hour. And maybe I'm flattering myself, but this should be under 1 hour. But let's try to build this one. So it didn't make it to the previous streams, but then one of the Patreon subscribers asked me about this one. And this is for you, and decided that, well, if the people are interested in this kind of website, let's build it. Because this is a really nice idea and looks pretty cool, right? Amazing effect. Hey, nice to see you, AJ. AJ35 Lightning. Thank you guys. Thank you guys. All right. Let's call this one, or maybe dict. I'm gonna give the credits to the developer in the description of the video. And this is exactly the place where all the stuff to donate is. All right, so let's run something. It's 11:04 Sunday morning in Kiev. Okay. First, I need to install everything. Then I also need to and everything. Just my general template. Do you have any course about three.js? I have a courses on the awards website. If you go into the awards academy, awards.com, you can find there a couple of courses by me. I mean, 2 courses by me about some HTML and WebGL connection. Yeah, so here we go. We got this simple template going. And we have to make this. So how do you go about creating this? Well, first of all, the best thing to do when you decompose some of the websites is to go into the network tab and see what are the images they're using. You could find that they're actually using the normal map for this one, and then they're using the displacement EXR, which you can't preview, but here it is saved. It looks like this, which is basically displacement map. And this would be a really short stream if it would be just setting the normal map and the displacement map, but this is just one more step to do this. Kind of a geometrical step, which I really like, and the step that I use to create yeah. So you might have seen it because I've made a couple of tutorials on the code drops on the tympanos. And one of them was this one. And this is actually kind of the same idea. So if you make the idea from this stream yours, you understand it, you can create stuff like that pretty easy, I think, because this is 100% based on the idea we're gonna exploit today and the idea that's been used by the guys, which is actually a pretty nice, sleek, elegant idea, I should say. So let's dig into this one. Well, first of all, let's use those images, right? I also downloaded the image that they used. It's just a PNG, just a square image. Let's get them all into the app. And I'm still using the same template. That's a random stripe. Yeah, it's actually a face. Alrighty, so what's gonna be first disp from XR, then normals from normal PNG, right? And then stickers from stickers PNG. So should be all right. Here we go. We have the first problem with the parcel because parcel needs some file types to be specified here. So I just need to list one more XR. Didn't use that one for a while now. All right. Now we have all of those, and like the way parcel works, you just get the URLs here. Get them, yeah. So here we go. I think it used to be just the relative URLs, but now it's just the absolute ones. I wonder why they changed something in the parcel. Anyway, we have the URLs for the images. Now we can try to even use them, yeah, right? So we have this plane. Maybe I should make it a little bit bigger. Back two, and then because by default it's just this simple geometry, make it more complicated. And then what I could do actually, duplicate this line and put the simplest material that has the displacement map and the normal map, and that be on material, I think, and then it's gonna be normal map, texture loader. Yeah, thanks Copilot. And then displacement map, which we can't use like this actually, but that's for the sake of creating another error. Try to do that. Try to use it like this. Right. Okay. We're gonna get some error probably because we can't really load EXR file with the texture loader. We need to load it with the EXR loader actually. Let's do just that. EXR texture loader. So how do you do this? First we need to import that one. So the same way as the loaders. So we got the EXR loader, and then how to use it? Well, same way as all the other loaders. And I'm gonna wrap this thing. I'm gonna use here disp texture. Here I don't need the function. Did I miss anything now? Fine. Gonna move all the things here. Hello, Honku trend. All right, so we gotta have the texture here, right? You have the data texture. This is how do you download the EXR. And the only reason they are using EXR is because it has more precision than the usual images, because I'm going to be using this one in the shader, obviously. And if you use the normal image, you have like 256 shades of gray. But with this one, you have obviously two bytes more, I think, right? So it's much more than that. Hello to Taiwan. All right. And then this displacement texture equals texture. Now I could use this displacement texture, the texture for my material right here. Yeah, just this. Now we have something. You could already see the face popping out, but the ears are pointing like forward, which is kind of crazy, which is exactly what we see on this image and exactly what we like achieved. But then we probably need to add some more lighting. So this ambient. I don't remember the exact lighting they are using there, but something like that probably. And then directional probably should be something like this. Wonder why we don't see shadows yet. Maybe the ambient is too much. Should see some shadows, to be honest. Wonder why we don't see them. Ambient light. Okay, so we added 2 ambient lights. Right, that makes sense. Yeah, so we have some shadows looking kind of ugly, but yeah, at least we have something. Now this doesn't look nearly as cool as this one, right? Obviously. And then we could actually add also the map just to see how it looks with the map. Things I don't need. And then map. What did I call it? Stickers. I call it stickers. This is kind of the basic thing. And then, okay. Is it make like this? No? Did any error? And valid value. Yeah, I guess that was enough. Just the transparent true. So now we have the image put on here, and it's kind of like almost almost got there, even in 10 minutes, but it's not what we actually want. Why do I always enable standard derivatives? Because you never know, you might need them. Because it's easier to delete them than to Google again how you should enable them. This is probably the motto of my development. Yeah, just the motto of my development. It's easier to delete stuff than to find that one on Google. So that's why I put a lot of stuff that I don't really need in every project to my template, because it's quite easy to delete those. But if you need to get them, you kind of, well, you can't remember this shit, right? If you want to get them, you need to Google, like, how do you call them, copy, paste, and it's like a minute or two, and it's like a second to delete those. So this is why. What do I unlock by enabling them? You unlock the operators like dx, dg, like the stuff that you need when you calculate in the smooth normal maps. That's what you call them, I guess. So this is the way to, usually it's the way to calculate smooth normal maps, but also I think just to smoothify, like if you want the grid lines, one, like how do you GLSL read? There used to be some, yeah, maybe this one doesn't really matter. If you go into any grid, you'll find that you're using the f width operator, which is just the only possible with the derivatives. And this is the thing that you need to create something crisp on your screen if you're drawing. It's a pretty complicated explanation if you Google it, but this is, well, in just 2 words, it's a way to create smooth stuff in GLSL. Right. So here we go. We created like this simple demo, which is not enough, obviously, right? If we can put, we can change like the position of those textures, but it's just not, not that cool. By the way, maybe I should make the ambient bigger now. Kind of want it brighter. Yeah, more like that. All right, yeah. So that's what we have. That's what we have. So how do we go from this to cool ones? First of all, I will need to use the same material, but I will upgrade it. So let's call it this material. And here, this material 1. So we should be back to, yeah, to just this. Let's experiment with this one. First, I'll show you the idea, and then we're going to implement this idea on an actual model. So we go to vertex fragment shader. You could do all kinds of distortion to this one, right? You could do new position, what? Z plus equals sign of something small, something big, and then, yeah, let's say this. So you could do all kinds of distortions. You could even make them bigger. And this might actually work, Like we could do not exactly this, but let's say maybe here you could do UVX instead of position X. And you could do some kind of this simple distortion and then put face on this one. But you could see that the edges of the face, they're kind of going behind the face, right? They're wrapping around it. So it's not actually the way to implement this kind of distortion. Create this distortion, we need something a little bit more complicated. And for this, I'm going to use GLSL rotate function. Where do I get maybe a simplest one? Yeah, so I think this one should return me. No, this is already rotating the thing. Yeah. So we have this one, and then what could I do with this one? I could invent some kind of vector, some kind of stupid vector, like let's say dump, stupid but dump, and then it's just the XY, so it's something pointing upwards. And then I could like to final position equals, and I can, okay, I can do this, right? I can rotate my new position, not this one, but I can rotate the dump one. And well, let's first actually test if we are doing like anything with this rotate function. Just want to make it slow. Okay, final position. Yeah, this will not get me an error at least, so I'm gonna do a new position XY, gonna be equal rotate, new position XY, and then 5, I don't know. And we got some errors because E, Y. Yeah, so you could see that this rotation is actually working, and I can even put time here, and it's gonna be rotating now. And I can rotate on any axis, right? This, probably YZ is gonna be the funniest. I mean, I have a weird perception of fun. Okay, but still, we have this. It works. So what I want to do, I want to rotate this dump vector depending on the x coordinate. And not only the x coordinate, I think, because the x is between -1 and 1, because we have the plane 2 size, 2 by 2. And this means that it spans the range between -1 and 1 on x and -1 and 1 on y. And to have something between 0 and 1, I can just use uvx in here. Right? So let's rotate. Let's like get this, and then final position is going to be rotating this dump vector with the uvx, and then, well, just that. Let's just use that. And then instead of, let's overwrite final position with this one. So first of all, I'm going to use final position x. Then I'm going to use the old position on the y. So I want to rotate this because I want to wrap it around on this axis. I need to preserve the y as it was before. So I'm going to leave this one y, and I'm going to create here final position. Because this one is a two-dimensional, I'm going to take the second one. So actually, like this vector, depending on the x position we are at, this vector is going to be something rotated. So it's kind of should be similar to what we are seeing right now, but different. So let's see, I've just overwrote the new position variable, and we got this. This is exactly 1 radian. I could see this with my naked eye, you know. But then, and this is actually pi. I don't know why I used this number, because it's actually 314, 15, like this. As far as I remember. Okay. So this is because this value is in the range between 0 and 1. If I multiply it with 2, which doesn't make any sense actually, I'm gonna get twice that. If I multiply it with pi, okay, I actually had pi all this time on top of my file, so I could have just looked it up. And I was bragging that I know first 6 numbers, first digits of the pi, even though I have a lot more. 10 lines. 10 lines. Yeah, I just realized that. Crazy. All right, so anyway, could you imagine that from just the plain thing, we just were able to create something around it now? And it's just crazy because we just rotated some dump vector. I mean, it's literally dump, it's just 0 and 1. Just 1, 0 and 1, 1. And it's that easy, but because we rotate it depending on the uvx, and uvx is changing between. So this is just a plane, and uvx is just these. And then we map each point on these UVs. We are just mapping them to the circle, because we are rotating with the angle between 0 and 2 pi's. So this vector, depending on the like uvx, which is 0 and 1, is gonna get us the full circle, because we're going the 2 pi rotation with this one. And then because the y, we're preserving the y, so the height of this whole thing is gonna be the same. You could see it. I mean, it's got closer to us, but the height is still 2, the same. But then every point on the xz plane got rotated into the circle. This is the magical thing. And this is how you create like more complicated shapes than just by displacing with the sign, like I showed you, right? So we're actually, yeah, we don't need this anymore. So we got this. So now, how to combine these two to create an actual pretty cool animation? You can already see kind of the next step. But there are a couple of ways to do that, obviously. So the autocomplete, well, sometimes it's just the Visual Studio Code syntax thing. Sometimes I think it's the Copilot, it's GitHub Copilot. It's an AI thing that tries to predict what you're gonna write. Pretty cool. Pretty cool. Okay. So where do we go from here? Okay. Now we are just back to the shader. And I want to use this material 1 again. And we are back to the flat kind of face. I also want to so let's get to business now. Business of creating faces. Okay, first of all, obviously this material 1 is not enough for me, but it has those nice like shadows, normal maps are working pretty fine, displacement map already in place. So it would be nice to use this one. To do this, we will need to patch it. In three.js, there is actually a way to patch existing materials. Maybe it's not a perfect one, but it's a thing like this. Function shader, then something's going to be happening here. Like to have all this stuff inside. Then what you can do here, well, first of all, whatever you're going to change here, you will actually need to save a copy of that, because this shader is going to do this. So this is the shader that we're getting, and it's actually like the material kind of thing, right? You have the fragment shader here, and this is the whole material. And because I will be using some custom uniforms, like you can already see, it tries to help me with that. In the end, we need to save this one, something, and user data is an actually like an actual thing that you need to save, some random stuff that you need to save in three.js. It is both in the shaders and in the materials. I mean, both in materials and in the meshes. So we're going to save this one here, and let's just progress. So I gotta have this user data shader. I'm gonna comment this one. Uniforms. Progress value. Stuff like that. I'm gonna get the error because this initiation takes some time. So what I need to do, right, because I'm not putting just the value, you could already see that, yeah, the value is 0 obviously, but yeah. So we have the uniform with the values thing there. So we have this custom material now, which doesn't change anything about the material. Let's get to it. First, we need to like patch it with some things. And there are some things that we need to patch it to. Here we start. On the shader, vertex shader, and replace it. Yeah, pilot knows what I'm doing here. But then we need to find the place we're going to be replacing and, well, to write the stuff that we're going to be replacing. Well, it proposes me begin vertex, which is might be, I think it's not the one. We need something like in the end. I think it's project vertex. And then I'm going to replace it with something similar. It shouldn't change anything except here in the bottom. But here we can already write our own code and do some, okay, Copilot already tries to help me with that. So Yeah, so we could play with, this is actually the inside three.js variable already. Oh, hello to Chicago. Okay, so transformed, where do we go? Let's go to the, let's go to that actual file and see what we can do there. I don't really remember which parts we should be, just roughly. The renderers, shaders, chunk, project vertex, yeah. So this is the thing we're going to be calculating here. So the only thing that it does, it actually, it's like the final position, the calculation of the final position of the vertex on the screen. So we will need to calculate all the things here. Obviously don't care about the instance in here. Transformed is an actual position on screen. So let's try to we're gonna just remove this one now and then see what's gonna happen. Okay, so it's gonna be transformed and then we need these two. This transformed, it's the thing that's been calculated after all the calculations, like concluding the displacement map, actually. So if I now comment this, yeah, still see stuff. Because if I comment everything now, I will not see anything. Yeah, because stuff is required, obviously, to see something on the screen. Now I don't care about this stuff. Now I can just to test stuff, I can do transformed c plus equals still the same. So this way you could patch the materials, hopefully. Okay, maybe I should make it before I calculate. Yeah, so now we still have the kind of the nose there and the face distortion, but we can distort this stuff now with our calculations. Now we need to get back to the to our functions that we've been using. And for that, I think I need to add things in here. And I will probably need the variants too, not just the uniforms. And I think flipping planes parse vertex. Yeah, it actually could be anything, but this one is, yeah, it includes some kind of variants, so we could use this one. So let's do the same thing. And then this, how was it called? Flipping planes. Parameters vertex, right? And then same goes here. And then I could add my newly created stuff. Like for example, the rotation function that I need. Copy this one in here. Let's just see if we're getting any kind of errors. So far so good. Okay. And what's the next thing? Next thing I will, well, eventually I will need some varying. Right now, maybe I could get away without them, right? It's gotta be fine. So next, let's move. We have the rotation function, but for later on we will need something more to put here. So we have this. So now it's about getting the position and getting the same rotation thing in here. We can't actually use this transform thing because it's already has a distortion inside of it. And let's remember that the plane is 2 by 2. Yeah, it's 2 by 2. It's right here. So we will need to play a little bit with the math to get there. So first of all, let's just create some kind of variable, which is going to be position xy. We still have the position in here, because if I just replace transformed like this one with position, I'm just going to get the plane. Yeah, you could still have the texture and the normal map applied, but we just get in the plane. Okay, back. So we need to calculate something about this transform that's gonna be like a face. How to do that? First, I'm gonna calculate position and I'm gonna multiply it with 0.5. This way, it has been between -1 and 1. Now it's gonna be between -0.5 and plus 0.5. Then I want to calculate again some kind of UVs, the same way that I had in the previous example. So let's calculate the float. U is going to be just for to be safe, plus x. Float U is going to be plus x, and then first we're going to make a cylinder, and then we're going to create something more interesting with the cylinders. And then UV is going to be not the fract possible. Good. The pos y is actually changing also between 0.5 and that, but I kind of want my UV to be like in front of me. So for this, I will need to normalize my UVs, because otherwise it's going to be with the minus sign. And here actually I can, like this way, this is going to be between 0 and 1, because it used to be between minus 0.5, and if I add 0.5, it's going to be between 0 and 1. So this is between 0 and 1 now. All right. And now I want to normalize this one between 0 and 1. I think at this point it only matters if it's on the screen, if it fits the whole screen, right? So maybe for this, let's leave it at that, and let's see what's gonna happen next. Now I kind of have the UVs. I'm gonna call this one like a displacement UV. Which I could use, and let's also v displacement, because I will need this displacement UV for the normal map as well. UV, and then I need to use it here. So we'll need to play a little bit more with this. Placement UV, and I will need to do the same in the fragment shader, of course. Do that right away so we have everything in place. I think this point could be common, and add something at the varying. So just something in the top of the file. Right, and then I want something inside my shader just to take the normal map. Got some errors now. Dimension mismatch. Because I set back 3. Gotta go back 2. Right. There we go. So far so good. Then I will, in the end, I will also need to replace normal map, so I'm gonna put it here as well. Normal fragment maps, this one is called. Copy this one. And then I'm gonna replace this one, right? Why is it highlighting the error here? Okay, because I copied the bracket. Brackets. This one, I don't actually need this one, right? Here, when I replaced, I need the bracket. Don't see anything, but at least in very what? Oh yeah, because I don't. I'm putting variant inside of the body of the shader. So okay, so now we actually don't do anything. We just like connect it to the API where we need to put something. And now let's do the magic finally. Hello to South Africa too. All right. So we have the displacement UV. We have the displacement happening here, but we want it to be custom. So we also have the displacement varying here. First of all, I'm going to calculate the actual displacement, which is going to be texture to displacement map displacement UV. Yeah, right. Thanks for that. This is going to be between 0 and 1. Then I need to normalize this to like -1 and 1 thing. So I'm calculating display. I'm not yet using the displacement, mind you, but still calculating the displacement. So we have this variable. Now I wanted to create this cylinder here. So the same way that I did previously. So I'm gonna select to rotated displacement, yeah, I guess. But then here I'm gonna again use some 0.1 thing, and here I'm gonna rotate with the probably U, right? It's between 0 and 1, or just position x plus 0.5 multiplied with 2 pi's. Do we have the pi here? I don't know. Okay, so this is the formula. We have the rotated displacement, just like in the previous demo. This is 2 pi multiplied by something between 0 and 1, and we are rotating some dump vector here. And then we could replace this transformed with that vector. First, let's see if we are getting any JLSL errors. No, that's fine. And now instead of these, I could use here something like this. It's going to be rotated displacement x, then the position y, and then the rotated displacement y. So just the same thing that I used before. And we can already see this thing wrapping around in a circle. We are getting there. The fun way to do here is also replace this dump vector with a displacement vector. So plot radius. This is going to be the radius of the face of the head. It's going to be variable between like the nose and the ears. So the radius is going to be, I think there were some kind of magic numbers that will make it beautiful. It's going to be like 0.5 plus, I don't know, 1 multiplied. I'm going to change this one in a second with the displacement. So this means because the face shouldn't have the radius 0 and the displacement is just 1 here. So this radius we could put here. We could already see something weird happening. This is not quite what I expected. The face should be the other way around, probably. I wonder why. Wonder why this is happening. So it's probably because of my rotation thing. I'm gonna change that in a second. But anyway, you get the idea. Now we wrap the face around. Maybe displacement. Okay, this is not the way to do this, obviously. So I think the numbers were in the original or something like this. It's gonna be a lot of fun. The ears are pretty big here. Okay, so now I think it's getting there. Now we could see the face actually. Maybe I shouldn't add this one here. Now the face is looking right at us. We are getting there, but then we need to scale this thing because the textures are wrapped too much in here. So I'll need to play a little bit with the numbers. So this position, because this one is the base for the calculation of the displacement map. And like something this. Okay, this is too much. I think I need to change a little bit this one between the I think I've arrived where I wanted, but too early. Let's leave it at that. So I need to scale things a little bit just to make it more beautiful. It's already kind of the thing that I wanted. But still, let's also add that's another variable. Make it default 0, 0. And then here I'm gonna add this one. Just to see how it will work for me. So you're right. On in here. Translate undeclared identifier. Yep. We'll need to declare this one. Right, and then we have the X and Y. Now in here in my shader, uniforms translate value X and the same for Y. You could see the X is actually translating the texture and the Y is actually changing the face, which is actually pretty cool animation, I should say. I think I messed up somewhere a little bit with the variables, so I need to change things here. Look closer to what I'm doing actually. I'm using position X in here. Should I be using position X? Yeah, probably. This is a displacement UV. It's just the two-dimensional representation of this. Cos Y is just 0.5. There's something wrong with the Y component here because it keeps changing the face, which is kind of cool. Because this one is working. They should only move the texture, to be honest. So the texture movement is in the I'm also wondering if the normal map is working correctly here. When I'm open, kind of the lighting is fine here. I messed up some calculations. It's pretty easy here, but something is a little bit off to me. Be wrong here. Maybe you spot the mistake. Yeah, I think I will not succeed with an under 1 hour stream again. Failing miserably. Okay, let's see. This is something wrong with the V or Y. Hmm. What's gonna happen if I multiply something in here? What's gonna happen? It's even weirder than I expected. I don't think I need fract here, to be honest. Might be part of me. Now we could see a traveling face. But why the hell it travels? It shouldn't be traveling, right? Shouldn't be traveling. Messed up somewhere. Only UV not position, but I'm calculating. Actually, UVs are kind of product of those positions. So this seems to be the right thing to do. And but yeah, actually working fine, except that I'm moving the. I could actually just translate the position. You're right. That messes up. Seems so obvious to me, but and there's some obvious math missing now. I think I gotta stretch it somewhere just to make it look more like a face as well. Maybe it's fake, just like a 0.5. More like a face that we need it to be. Yeah, exactly. Sometimes you need to just play with this stuff. So we have the X figured out, but the Y is wrong. The V is gonna be. I should multiply this then. Let's try to throw some random numbers and see how it how it works out for us. Yeah, I actually love it. It's like a cylinder turning into the face. This is the place where like the errors are even cooler than the actual output we are getting. The face is okay, it's all right. We got those face, but then the actual output is pretty funny. This somewhere a simple dumbest mistake. What could be that mistake? So again, position, it's gonna XY. One, I think in the original shader they actually used some kind of mapping function there. Maybe that's the key. Maybe because I didn't use the map function, maybe that brought me this mayhem of errors here. Displacement is correct. The only thing is not correct is the displacement is not correct, right? But if I just here, no. It's even funnier than it was actually. Ooh, we're gonna have so much fun with this one. Okay, there's somewhere a simple dumb mistake. I'm gonna give myself another 3 minutes to figure this one out, but otherwise I think we pretty much figured it out. And gotta be all right now. So, okay, I'm gonna try to stick to the one that's used in there. Let's try to use exactly the method that they used. So we have the position, which is the translated thing, and then we have the u is the fract position plus 0.5, which is normalized and which is working fine. And then the v is going to be the map function, our map position y, and here for 1, so I'm going to map something on the screen. And it's got to be it. And then the displacement is going to be just the uv. And then we're going to get the displacement value. And we're going to get the radius. Then we're going to rotate this whole thing depending on the position x. Bring it back. Still we have the moving face. I wonder why shouldn't be having it actually. Now we have a much cooler moving face. I think we have the displacement map moving, right? Why the hell does it move? Because I had translate to that one, right? What if I don't add translation to the displacement map? Placement UV, V. If I use something in here, it's just position Y. Kind of. At least it's not breaking now, but it's not moving too. Actually, I thought the texture should be moving in here, but why the texture is not moving? It's probably... Well, I mean, to be honest, you could just offset the texture and this is it. Let's just let's move the texture in here. So this could be easily achieved with this. And then. How do we change the offset? Offset is a two-dimensional thing, so say that use offset should this be working? Yeah, I mean we have the texture moving around now. I only needed the diffuse texture to move, and this means again actually have a whole thing rotated now. But I only wanted to move the diffuse texture. This diffuse texture. Why the hell is moving all the textures for me now? Ah! I don't know why, it's just a dumbest mistake, probably missed sign or something. Oh, it's actually correct. the thing that is not correct. Oh, it's always like that. Because I created this whole thing, but I never really used the displacement UV here. And this is why I'm seeing it's kind of rotating, but it's not really rotating, actually correct. So here, actually, normal, I'm gonna have the texture 2D, gonna be the normal map, displacement UV. This is not it. I think I gotta normalize it and then like that. And just to check if I'm actually doing anything. Diffuse RGB. Yeah, so this is the right place. And the texture wraps correctly. And it wraps correctly from... You know what? It's because the normal map was moving as well, because I didn't use the correct displacement UVs for the normal map. We had an illusion. It didn't really move the displacement map. You could see it stays in the same spot still. I just changed normal map. But we had an illusion that it actually moves. And this made me think that I'm doing something wrong, but I was actually doing everything right. I just forgot to add this last thing because I wanted to make it the final touch, but it is actually the inevitable touch that you need to do. All right, now we need to remove this. Now I need to scale back the face. I think it should multiply here or something. So here we go. Now we have the texture wrapping the face from bottom. I could also wrap it from below. And then I could just encode the y as an x. So I can do this as a function. So I'm going to be just changing the x. Or maybe just the y. Just the y. And then the x is going to be function from the y. It's going to be same, maybe. Yeah, kind of. You could see how it's wrapping now around. I think somewhere it should be a fract. I should say it said something in the texture. So here you go. We got it finally. And you know what? It wasn't even a mistake. Everything was right. It was working as intended. And I spent a lot of time just fixing something that I just needed to, because you know, like the reason of all of this, because we are changing the displacement UV, because we're making displacement UV to use the face thing, we still need them to use the same UVs, the displacement and the normal map, because that way it looks real for the eye. Like first displaces the image and then it uses those shadows, because it's not the real kind of 3D shadows, it's just the normal map shadows. So this is what was needed. We had an illusion of mistake. Yeah, sometimes it's easy to write your own, yeah, because you have a control of everything. But here goes it. This is how it is created. I think we could also like what? The X should have been the fract. Still, it's working fine. So here goes the thing. So the most important stuff in here was that we are wrapped around with the geometrical thing, like we rotated the position to make it a circular, and then we created this kind of shape. Yeah, and we also had the dump mistake, which we luckily fixed during the stream. It would be so not satisfying to go offline without fixing this mistake. Yeah, so here it is. I think we can, the Y could be smaller just so I could enjoy it more. Yeah. And this is actual 3D thing, so pretty cool, right? The idea is actually pretty cool, even though it took us an hour. I mean, 20 minutes from that hour is just fixing an existent mistake. But still, a lot of fun, right? With the shaders. And you could actually do this with a different normal maps. So if you go to normal map online, let's just complicate things a little bit more now. And if I just download these, could be anything actually, but let's I need all of them. So I need displacement map. Let's see how it works with the PNGs. I need displacement map. I need normal map, obviously. So it's this one and normal one. Let's try to see how we could use anything. So it's normal one, and then it's going to be one PNG. Then instead of the EXR loader, we gotta use the this probably should do the trick. Let's see. Well, this is obviously not a face anymore, but we could see our like 3D thing wrapping around this shape now with kind of a shadows and anything. So with this idea you could do anything, but you could see it's not as smooth as it used to be, but still you could wrap around any texture, any kind of displaced shape with this technique. I mean, as long as it's spherical or something, right? You can wrap the texture like this, and pretty cool. Pretty cool. Hello everybody, hope you like this stream. You know, actually, like, doing this stuff is sometimes it's pretty fast, sometimes it's pretty damn slow. I think I would also need to normalize the UVs of the texture so it looks better. So it's just a lot of playing with the mess. Let's bring back the face. But with this face, you know, any multiplication here would change it completely. Let's say I'm gonna scale it to maybe a pretty long face. Also, I could bring back the diffuse. Kind of a green face, but we are still using the other normal map, you could see. And yeah, now it's correct one. I want to see the whole face. So this is how it actually looks like. We didn't wrap it like the whole face, but we don't need to. I mean, right now nothing is moving because it's all with the color. Still pretty cool. And here's the the edge where it's on the edge. By the way, I think if I just remove 0.5, it's going to be just facing the other way. Going to be facing the other way. So you need this because actually this U is used to wrap the texture correctly. Yeah, to move it, like rotate it with the pi. You could make all kind of faces with this. I think 3 is somewhere. Also depends on the camera, like direction you're looking at. This looks pretty realistic to me. All right, anyway, hope you like that one. If you want to support me, go to Patreon. If you want to support my initiative, my volunteering initiative to help my friend in the army, all the things are in the description. So, hope you like this kind of streaming. Hope I will be able to stream next week as well. And let's see what simple shader animations we will see in future. Thank you for supporting me, guys, and see you in the next one. If you love someone, say them that you love them this week and do something good to the world.